Everyone, this is an explanation of practice problem B in your inverse graphing unit. So first thing I've done here, I've already done the work, but I solved for the inverse function. So check out my work here. I swapped out f of x for y. I switched where x and y were in the equation. And now I've started solving for this y value. First thing I did was divide by 2 on both sides. That gets rid of the coefficient out front. Then I cubed each side to get rid of the cube root. And finally, I added 4 to each side. So my inverse function is x over 2 all cubed plus 4. So now I've taken that problem over to Desmos and I've inputted each value. Okay. The red line is our original function. I wrote my cube root with rational exponential notation. And then the blue function is my inverse function. Now, what this confirms to me is that they are inverses of each other because they are a reflection over the line y equals x, which is the green line. So if I need to get a sketch on my piece of paper, I need some key values. So Desmos offers me lots of gray points on each function, and take a look at all those points. They are reverse of each other. They're inverse points, and they're going to help me graph this line. So for my original function, which is the red line, I'm going to graph the point 4, 0, and I'm going to graph the point 0, negative 3.1-ish. So you're going to have to estimate there. This is just a sketch. And I'm going to graph the point negative 4, negative 4. Now notice the curvature of that line. It's a cubic function, and I want to maintain that curvature when I graph this out. So it connects these points, but it also has a nice curved feature. Sort of looks like a sideways parabola there. And then when you go back to the function, it hits the y-intercept and curves the opposite direction, going the other way. So I want to maintain that structure. Okay. I'm going to switch colors here and go back and graph the, sketch out the inverse function. So now I'm going to sketch out the the blue line, which just has the inverse points. I'm going to plot the point over 0 up 4. I'm going to plot the point negative 3.1, comma 0. So that's an estimated point. And I'm going to plot the point negative 4, negative 4. Now again, I want to maintain the structure of this line. So as I come up, it has a curve that looks like kind of a reflected half of a parabola. Then I hit the y-intercept and it reverses that curve. So when I graph that, I want to, again, maintain that structure. I start with a curve as I come up, hit the x-intercept, and then reverse the curve. This is going to maintain the cubic function structure. Now, these are just sketches, so they're not perfect, but I think you can see what we're trying to build here is a reflection over the line y equals x, and I'm just dashing in that line. So I wouldn't say that's a great drawing by any means, but it's not too bad. All right, happy studying.